In Chapter 3, Section 2, we're going to focus on parallel lines and transversals. We're going to be using them. In the last section, we learned to identify them and we learned to name certain angle relationships that fell within them. Now we're going to actually use them. So we're going to go to the postulates and theorems list, and we're going to have to talk about some of these theorems. Notice there's 4 theorems on this slide. And what it's talking about is if 2 parallel lines happen to be crossed by a transversal. So this is very specific. Remember, in the slide that we talked about in 3.1, any 2 lines could be intersected by a 3rd line called a transversal. Now, if those first 2 lines happen to be parallel, and then they're crossed by a transversal, then all of a sudden, a bunch of angle relationships and values appear. So the first one is corresponding angles theorem, which says that if parallel lines are cut by a transversal, the corresponding angles are going to be congruent. So let's just draw. Remember the other day we drew 2 lines. We drew line J and we had line K. Now the difference between the other day is that J and K are parallel to each other. And then here, I'm going to draw my transversal. Remember, my transversal, I always kind of draw it in green. And when I draw that transversal, all of a sudden, I'm going to get 8 angles out of this. 5, 6, 7, and 8. Now, when we're talking about these corresponding angles, what we're talking about, again, is remember that the corresponding angles are the angles that are on the same location of the 2 lines, relevant to both lines. So, for example, angle 1 and angle 5 constitute corresponding angles. And so in this, angle 1 would be congruent to angle 5. Not only are they corresponding, but they're congruent. Another pair of corresponding would be 2 and 6. Remember that angle 2 is congruent to angle 6 because of this theorem, but they're corresponding because they're on the same location. Notice angle 2 and 6 are above lines J and K and to the right of the transversal. And again, you can kind of go through here and do these yourself, right? We've got 3 and 7. So I know that angle 3, based on this theorem now, angle 3 is congruent to angle 7. And then the last one is going to be angle 4 is congruent to angle 8. So whether the lines are parallel or not, whether J and K are parallel or not, these angle pairs are corresponding. But now if J and K are parallel, all of a sudden they're more than just corresponding. They're now congruent. Which means if angle 1 equals 100 degrees, guess what? Angle 5 also equals 100 degrees. The next one we're going to go to is we're going to go to alternate interior angles theorem. And what this tells you, again, if parallel lines are cut by a transversal, then the alternate interior angles are congruent as well. So again, let's find our alternate interior angles. Let me see if I can just, whoops, I don't want to do that. Let's put this back in here, 3. Okay, so my alternate interior angles, remember that interior means the angles on the inside in between the 2 original lines. So in between lines J and K. So our interior angles are 3, 4, 5, and 6. But our alternate interior angles are angle 3 and angle 6, and angle 4 and angle 5. Those are our pairs, 3 and 6, and 4 and 5. And what, again, this theorem is saying is that those angles are congruent. Now notice, it's when the lines, the original 2 lines, are parallel. So again, if they're not parallel, at least we know they're alternate interiors, but once we know they're parallel, we know they're equal as well. And so that makes a big difference, because if I know that angle 3 measures 70 degrees, then I know angle 6 measures 70 degrees. The next one we're going to go to is our alternate exterior angles theorem, which says that alternate exterior angles are congruent. So again, remember the exterior are the parts above and below the original lines. So it's angles 1 and 2 and angles 7 and 8. And so when I'm talking about alternate exterior angle pairs, I know that I'm talking about angle 1 and angle 8 and angle 2 and angle 7. And again, this theorem is telling me that when the original lines are parallel, these angles are congruent. And so yet again, another great relationship to know. And there is one more relationship, and it is the one that is different from the other ones, okay? Notice that this one says they're congruent. This one says they're congruent. This one says they're congruent. The consecutive interior angles theorem says that the consecutive interior angles are supplementary. So this one says that their sum is 180 degrees. Well, it tells us they're supplementary, and then we can conclude that their sum is 180 because of the definition of supplementary angles. And so consecutive interior, remember, these are our same side interior angles. So when I look again in the interior, I know that's 3, 4, 5, and 6. And the interior angle pairs are angle 3 and angle 5, and angle 4 and angle 6. And so what this one tells me is 3 and 5 are supplementary. And this one tells me that 3 and 5 are supplementary. So what does that mean? That means that angle 3 plus angle 5 must equal 180 degrees. And angle 4 plus angle 6 must also equal 180 degrees because of definition of supplementary angles. So again, all of these congruent and supplementary things you're learning about today is because the original lines happen to be parallel. So let's do some problems with this. It says find the measure of each angle. And again, you're going to notice, and I'm going to stick to what we're doing here, we have this original line here. Let's call this line J. We've got this line, which let's call it line K to be consistent. And notice these little triangles here. This represents parallel. So those two lines are parallel. And if you notice, they're cut by two transversals, really. I'm going to focus first on this transversal here. This line intersects and creates these 8 angles. Now, I know the line's a little bit off, so it's a little bit weird to see there. Let me just kind of draw the line. So the line really should go a little bit like this, so you can kind of see those other angles, okay? So let's talk about the different angle pairs. So the first one, the measure of angle 1. Well, I'm not really sure, right? But let's look at the one that was given. If this angle over here was given, remember all those theorems now come into play because the original two sides, or the original two segments, J and K, were parallel. So I know, for example, corresponding angles are congruent. Well, what angle corresponds with 130 degrees? Angle 2. So I know that angle 2 must equal 130 degrees because of corresponding angles. Then I know the same side interior angles must be supplementary. So I know that angle 4 plus the 130 degree angle must equal 180. That means, using subtraction property of equality, for example, that angle 4 must be 50 degrees. So I know that angle 4 is 50 degrees. Well, now that I have angles 1 and 2, believe it or not, I can really, or angles 2 and 4, I basically can solve every question here, and I'm going to show you why. So I've got here the 130 degree angle, and I have here the 50 degree angle. Okay, well, again, I could say to myself, alternate interior angles are equal, so if angle 4 is 50, then angle 5 is an alternate interior. It's also equal to 50. I also know angle 5 is equal to 50 because if you notice, angle 5 and the original 130 degree angle form a linear pair. And linear pairs are supplementary, so that could have also helped me there. I know, again, being that alternate interior angles are congruent, then I know that angle 3 is alternate interior to this 130, which means angle 3 is also 130 degrees. Again, angle 3 and 4 form a linear pair, so I could have answered it that way as well. I already know, I said angle 5 was 50. And then using, for example, corresponding angles, right? If angle 3 is 130, then angle 6 is also 130 because that's corresponding. If angle, let's say 5 is 50 degrees, I know angle 1 is also 50 because that's corresponding angles. Angle 7 is corresponding with angle 4, and so I know it's got to be equal. And again, you're seeing the pattern. Once you know the two different angles here, they're all going to be one or the other. And angle 8 is, I'm assuming, this one that was never, oh, no, it's not. Angle 8 is actually over here. Now, angle 8 is 90 degrees. Now, you might say, well, how do you know that? Well, again, it has the box, first of all. And second, notice that it follows this transversal here. And if this angle here is a right angle, it corresponds with angle 8. So therefore, it is also a right angle, which means it's 90 degrees. And so, again, that's how we solve all of these problems. Now, was there another way? Was there other things you could have done? Yeah. If I look back here, once I knew the original angle was, once I come back over here and I knew this original one was 130, right? I could have known that angle 6 was 130 because these two are vertical angles. And using linear pair, I would have known 50 and I would have known 50. So between linear pairs and vertical angles, as long as I have one of these four, I can solve for the rest. And then I could use the theorems to apply this up here. Again, correspondings are going to match, right? And so I know this would have been 50 and 130 for angles 1 and 2, and then I could have used, again, vertical angles and linear pairs. So lots of different ways to prove something. Over here it says find the missing value, and again when I look, I basically have here, and this is where it gets a little bit complicated, is when we have multiple lines, multiple transversals. So if I'm going to really look at this, right, I have to start out picking, well, what two lines am I going to start with? For example, if I start with these two lines and, for example, this transversal here, then I'm going to focus on this angle and this angle because I see that those angles are corresponding. So because they're corresponding, I know that they're congruent. And how do I know that? Well, because this line and this line is parallel. So I know the corresponding angle congruence theorem says that. So 2z is going to be congruent or equal to 110 degrees. And if I divide both sides by 2, I'm going to get that z is 55. So I have my first answer, okay? Now I'm going to use a different transversal. I'm going to come over here and I'm going to assume this is a transversal here. But notice this is a little bit more difficult because all this says is angle x is corresponding with angle 2y. So angle x equals angle 2y. Or not even angle x really. The value x is equal to the value 2y. Now the problem is I don't know what x or y is, so this is an equation with two variables, very difficult to solve. So what I'm going to do is I'm going to re-look at this picture and I'm going to recognize that I also happen to have another pair of parallel lines here. I have this one and this one, and if you notice, I also have a transversal here. And so if I use this transversal instead, I notice that this angle and this angle are corresponding, are not corresponding, they are consecutive same side interior angles, right? Consecutive or same side. And I know that they are supplementary. So I know that angle x plus 110 must equal 180 degrees. And that means angle x equals 70 degrees. And so now I'm able to use that theorem to tell me that x is 70. And so now that I know that x is 70, now I'm able to go back and utilize that. I can either say, well, I know angle x and angle 2y are corresponding, and I know that corresponding angles are congruent, so I can say I know that x equals 2y, so 70 equals 2y, which means y equals 35. So y is 35, okay? Now, the other relationship I could have used if I wanted to keep using these parallel lines here and this transversal, right? I recognize that 2y and 2z are also same side interiors. Kind of would be erasing all that, right? these would be same side interior. And so I know that 2y plus 2z must equal 180 degrees. Well, if I didn't know what y was, I did know what z was. 2 times 55 is 180. So I would get 2y plus 110 is 180. 2y equals 70. And y equals 35. And I could have also found this. So when we ask you to find these, you're going to find them in different ways. But again, in this particular problem, we had lots of options available to us. And sometimes you have to find one variable before you can find another. Here's another question. It says, when sunlight enters a drop of rain, different colors of light leave the drop at different angles. This process is what makes a rainbow. For violet light, the measure of angle 2 equals 40. What is the measure of angle 1? How do you know? Okay, well, let's look at this, right? First of all, we're going to notice that they drew in the picture, because what are you learning? You're learning about parallel lines crossed by a transversal. And if you notice this yellow line here, that's equivalent to kind of like the red ones we did, right? I draw red to show you parallel lines. And then the transversal is this one here, okay? And so I noticed that angle 2 here and angle 1 are on the inside of the original lines, and they're on opposite sides or alternate sides of the transversal. So I know that angle 1 and angle 2 are alternate interior angles. Okay, so first of all, you want to definitely name them. You got to know what their relationship is. Now that I know that they're alternate interior, and I know my original two lines are parallel, notice they gave us these little arrowheads to tell us they were parallel. That means the alternate angle congruence theorem says that angle 1 and angle 2 are congruent. So if angle 2 is 40, then I know that the measure of angle 1 must equal the same thing, and it is also 40. So I know that it's 40 degrees, and how do I know it? I know it because of the alternate interior angles theorem. Alternate interior angles theorem, which says that alternate interior angles are congruent. So now we're going to try to complete a proof, a two-column proof. So again, we're going to start the way we start all of our proofs. Statements go on the left, and then reasons go on the right. And we're always going to start step 1 with what was given to us in the problem. So we know that what's given to us is that line P is parallel to line Q. So again, we're talking about these original lines, and our transversal here is T. And so they want us to prove that the measure of angle 1 is congruent to the measure of angle 2. And there's so many ways to prove this, okay? One of the problems with this proof is that they didn't really guide us as to what they wanted us to use or not use. In other words, sometimes they're going to ask you to prove things, but they're going to tell you not to use certain theorems. In other words, here, angles 1 and 2, these are alternate interior angles. And so obviously the quickest way to prove this is just to use the alternate interior angles theorem. In other words, P is parallel to Q, that's given. Number 2, I could say angle 1 and angle 2 are alternate interior angles. Okay, how do I know they're alternate interior angles? Because of the definition of alternate interior angles. I know that they meet the criteria. I learned about alternate interior angles in 3.1. So the definition tells me they're alternate interior, and then number 3 tells me that angle 1 is where I'm stating that angle 1 and angle 2 are congruent, okay? And here, that's going to come from the alternate interior angle congruence theorem. Or not even congruence theorem, I think it's just alternate interior angle theorem, which tells me that the alternate interior angles are congruent. Now, oftentimes, okay, this is like an unrestricted proof, basically. I'm proving this, and I don't have any restrictions. However, sometimes they're going to ask you to prove things, and they're going to tell you to specifically not use certain theorems, okay? So, for example, here, and I'm not sure exactly which one they wanted here, but let's just say if I wanted to prove this, without using the obvious theorem, which is the alternate interior angles theorem. Okay, so how would you prove this if you couldn't use this theorem? Okay, it would take a little bit longer, but you could. So you would start out and you would say, okay, number one, line P is parallel to line Q, and that's given. The second thing I would do here is I would say, for number two, I would say that angle 1 and angle 3 also have a relationship. They are corresponding angles, right? And how do I know that? Again, I know they're corresponding angles because I know the definition of corresponding angles. I learned in 3.1 what that was. Definition of corresponding angles. So then in number 3, I'm going to say angle 1 is congruent to angle 3. And I know that because of the corresponding angles theorem. Okay, I know that that means they're congruent, right? So it might be the corresponding angles congruence theorem. I feel like the word congruent is in it, okay? But anyway, it's that theorem that tells me that angle 1 and angle 3 are equal. Then I know that in step 4, I know that angle 3 and angle 2 are vertical angles. And I know there are vertical angles. And I know that because of the definition of vertical angles. And furthermore, I know that angle 3 is congruent to angle 2. And I know that one because of vertical angles congruence theorem, right? So I know 3 and 2 are equal. So now for 6, I can say angle 1 is congruent to angle 2. And notice what I did here. I know that 1 is congruent to 3, 3 is congruent to 2, so 1 is congruent to 2. I could either use the transitive property of congruence, or I could have used substitution property. Either one would have given me this, okay? So either one of those. And so this took a little bit longer to prove because I had to go more roundabout. I had to prove that 1 and 3 were equal. Then I had to prove that 3 and 2 were equal, and therefore 1 and 2 were equal or congruent. And so again, a lot of times the proofs are going to matter, are going to depend on how you write the proof, is going to depend on what you can use and what you can't use. So I would use this longer one if I had to prove it congruent without using alternate interior. Because they're alternate interiors, obviously using alternate interior is going to be a much shorter proof.